Nice to be here. I will turn off my camera to save some bandwidth, but hopefully everything will be okay. If there's anything, I guess Wolfgang can step in at any time. So hope you enjoy, and I'll see you with the FAQ afterwards. So Superuse. We are an, as mentioned, international collective of architects, designers, and people with a like-minded mission and vision on how to reuse waste materials in architecture. And we've done this on several scales, several kinds of projects, and I will just show a few of them to give you an idea of how we work, what we do, and yeah, what we think is important in architecture. So the title for today was Creating Urban Ecosystems from Valuable Residual Flows, and we'll look at that from various perspectives. If there's any questions, please write them down, and we can go back to either the projects or the questions afterwards. So currently I'm in Rotterdam, in Blue City, one of our projects, and we're working here with a team of 10 to 20 people, depending of course on the season, on the year, and the projects that we have. And we have like a relatively small core of 5 to 10 people, and then that grows every time. And as mentioned, I joined the studio in 2006, before I graduated, even during an internship, and I never left. So after my graduation, I became an employee, and short after, one of the partners of the firm. And well, I've been here for 15 years now, and I've never worked in another office, and this is really my work or my job, and really love doing this with our team every day. Besides Superuse in Rotterdam, we have a studio called Superuse on Site. One of the founders wanted to work in closer collaboration with clients actually on site, and is doing that mainly in the Netherlands, but that might move abroad as well soon. And there's an office in China called Superuse China, where we work more on urban scale projects and interior architecture. And currently we're in the process of starting Superuse North America for the projects that we think that will happen there in the near future. Before I dive into our work, I want to share a bit of things about climate change, which I hope you all know, but still it's sometimes good to see or to reflect back upon it. So these warming stripes are a graphic depicting the annual change in the average global temperature, and I think it's quite important to understand that this is a process that is really slow and basically has the same principles as the COVID pandemic, where we want to flatten the curve in a lot of places so that we can manage it in a way. And currently we're not really doing, I don't think we're doing the best we can, at least not well enough to flatten the curve on climate change to make it manageable for the next decades or century. And there's a lot of tools developed to help us as designers to define what are we working on? Are we working, which project boundaries? Are we working with sustainable development goals, etc.? And one of them is the butterfly model of the Ellen MacArthur Foundation, where you can look at materials in two cycles, mainly the biological cycle and the technological cycle. And of course, we are working on, a lot of it is in the technological cycle, where we reuse materials that are already existing, but it can also be from the other cycle. And more recently, Kate Rayworth developed the donut economy model, which I think can be really important for the way the architecture profession develops in the future, where you can say that a good project in a regenerative and distributive economy has a social foundation and an ecological ceiling. And currently, a lot of talks about sustainability in architecture are only about the ecological ceiling. We want to reduce climate emissions, we want to save water, save energy, etc., etc. But the social foundation is just as important. I think that's one of the core things that where we move from sustainable architecture towards regenerative architecture is something that we can include and justify better, how we balance between the green aspects, the ecological ceiling, and the, let's say, social foundation, so the more human level aspects. Well, in our office we work a lot with Stuart Brand's model of layers, where we really look at these different elements in a building, for example, the skin, the facade, that can be taken apart and reused, but also other surfaces should not be, well, endlessly intertwined in a way that they can't disconnect from each other. Another simple tool that we developed ourselves is this decision tree. So to make this choice between working in the technological cycle or in the biological cycle, our first option is always looking for ways to prevent material use. And of course, when making architecture, you can't discard every use of materials because you're making spaces. And our first choice is to use reused materials, either directly or transformed. And of course, the transformation should be relatively small to limit the amount of energy you put in. When we cannot find options to be reused, we'll look for the bio-based, so the biological cycle of the butterfly model. And when these things don't really work, we can look for recycled options, or in the end, conventional options like traditional architecture, traditional building sector does. And for our projects, that means that we change the way we develop a project. Usually you go from a sketch design towards the preliminary design, towards building preparation and construction. But we add a few steps in that standard scheme, where the inventory phase is really important at the beginning of a project, identifying local pains and problems that might be architectural, spatial, but also social, to get a good idea of the context. From this inventory that I will explain a little bit more about in the next slide, we go towards that sketch design where we don't know the materials yet, but we do know, okay, we will probably have 25% or 50% windows, openings, and based on a harvest map, we find and select materials that we can use, and with those materials we make the real design that we can use to get a building permit. From that building permit, you go preferably into a dynamic final design stage where buying materials, preparation for the building itself, and construction might sort of go back and forth all the time. And eventually, in the end, we like to calculate the environmental impact if it's possible, and aftercare means that we go back to our projects from time to time to talk to the client, hear what the how they perceive it when it's done, if there's anything missing or anything maybe better than expected. So going back to that inventory phase, that means that we look at flows, and we look at all kinds of flows, usually for a project when you select 2, 3, or 4 to really work on. That will be sufficient, and as any architect, the users are basically always part of that. But sometimes a project is more about traffic, or more about electricity, or more maybe about identity and culture. And one of the main things to take away from this is that some of these flows are really fast and almost invisible. For example, electricity, when you switch on the light, almost instantly the light turns on. But still, that is a movement of electricity from that switch where the connection is made to the lamp. Other flows like identity and culture are really slow and can be processes of 10, 20, or even more years, where you can see that we're currently in a cultural shift from being meat eaters to plant eaters, which might take another 50 years, but eventually I think we will see that eating meat will be declining compared to all alternatives. So what that means in projects, and one of these stories is BladeMate. Currently, I'm putting a lot of time into BladeMate, which is a startup basically. We have made some projects in the past looking at wind turbines, and we're trying to make that into a separate business to really tackle the problem of BladeMate or blade waste basically. And well, probably you all know wind turbines as an icon of the sustainable energy movement, but you rarely see the backside of it. And part of it is how they are made. So it's a combination of highly technological labor to calculate how to harvest the energy from the wind. And these blades, well, they're getting bigger and bigger, up to 90 meters or up to 100 meters. But that also means that, well, we're replacing blades, and They're maintaining the blades and building the blades by hand, so it's technological labor, university graduates that work on these new technologies, but also just people working by hand, putting glass fiber sheets in that shape and really making the physical product. But then in the end, we discard the blades. We throw them away. They end up in either like industrial sites like this, left to rot, or in the US, in Wyoming, they landfill them. Hundreds of blades chopped into large pieces, and you can see the bulldozer on the right top of the screen. This is really a massive scale of landfill that is, I think, even for the US, although they have a lot of space, quite shocking. And in Europe, we actually chop them to pieces and we incinerate them, or and we try to burn them, recover some energy. But still, there's a lot of scrap and ash after that that has to be landfilled anyway, or at least stored somewhere. Because currently we have no good recycling alternatives, and we're working on that as a society. We're working on that, not we as an office. Well, to change that and to make it recyclable, and they're trying to add glass fiber to concrete to, sort of recycle the waste in concrete products. But I think that's just polluting the concrete for future reuse. So we are looking for options to reuse the blades as they are in projects. And one of these examples is a playground in Rotterdam that we've designed 12 years ago or 13 years ago. And this was the first blade made project that we did. And once we were doing it, while we were doing it, we knew that it wouldn't be the last. Because, when it was finished, it's such a wonderful place that sparks the imagination of children. So they are not forced to be pirates on a ship anymore or knights in a castle. They can be anything they want in here. So the one day they can play that this is a rabbit's hole, and another day they can play that it's a spaceship. So for this playground, we used 5 blades of about 25 meters long, and we researched around the time that we thought that the flow in the Netherlands would be roughly 200 blades per year, 10 years ago. So currently that flow is getting larger and larger. So we have one blade that is still at full length, so you can see the part where the tip of the blade connects here, and that has become a lunch table. But when lunch is gone, the parents are gone, it's also just a diving board, and you can walk the plank or jump in the chipped wood ground cover. But what's even more amazing, when you go to the other side of this blade and you go inside, you see a space that we really would not have been able to design if it was not for the given shape of the blade that was designed by the engineers to harvest the energy out of the moving wind. So at the base of the blade, it's 1.4 meters high, so kids can just run in and crawl through. As you can see, if you're an adult, you have to get on your knees in the back. And all the openings are made specifically where they need to be according to health and safety rules. Because the blade slowly becomes smaller, you need more openings and more places where you can exit. So with the current flow that we think of blades in the Netherlands, we can probably make 100 playgrounds a year, but we don't really think or see currently a demand for 100 playgrounds a year. So what could we do besides that? Because this playground reduces roughly 90% on carbon emissions compared to a standard playground of stainless steel, sustainable wood towers. So the same size, the same roughly amount of play opportunities can be, a lot more polluting than what our recycle or reused solution is. So after this playground, we did happen to get a few other projects with blades, and one of them is also in Rotterdam. It's urban furniture, and roughly 10 years ago. And these 9 blades are only 6 meters long, so they're relatively small. And the request was for an object that can be moved around. So it's in a fixed place, but when there's an event on the square, they can disconnect, lift the blocks with the blades and put it somewhere in a corner so they can have the full square for a concert or whatever. And also it should be nice when it's in full use with lots of people on it, but it should also be nice as a sculptural object in space when you're just a few people walking by. And recently, the past year, it got a new paint job, and with that a new meaning. So an extra layer of meaning has been added to it. Graffiti artist Mr. June spray painted rainbow ribbons around it to make a LGBTQ plus monument. So it's a place where those people can come together. They can either commemorate, remember, protest, or just have a happy get together, have some drinks. And it's really nice that you can, well, the blades are such strong, they're such a strong identity and such a strong shape on their own that you can easily add another layer of meaning like this to the object as it was. But more recently, we made another playground on the beach in Terneuzen, a city along the Dutch coast. And it's roughly the same idea, of course, in a unique configuration, because all blade-made installations are one-offs right now. And that is something that we want to change, because some of these things you can quite easily make more repetitive. For example, a tower like this with climbing grips, you can make 10 of those and just place them in a playground as a single object. So throwing those blades away is a real waste of potential. Finally, on blade-made, another really close by to the playground, there's this piece of at the end of the pier, where 3 small sections have been put in a sculptural configuration. So it's an art object. It marks the end of the pier, but it's also a place where you can sit down, or actually when you stand inside, you can see how big they actually are. And well, just a smaller thing, or bigger thing if you want, on a recycling center that we designed in Maastricht, so pretty close to Germany and Belgium. There's this recycling center, and one blade is put as a billboard. It was meant to play a part in the ventilation system of the building itself, but that proved to be quite hard to calculate for the environment, or the, what do you call it? Well, mechanical engineers. So in the end, it's just a billboard, but still it's a pretty good place to store these objects for a long time until recycling methods are actually cheap and sustainable. So one of the things that you might wonder is, how do you get these materials? How do you find the blades? Or anything else in our projects, because with this recycling center, of course, the window frames come from demolition projects nearby, the steel sheets come as leftovers from factories nearby, etc. For that, we developed a platform called Harvest Map, which we last year sold to New Horizon, an urban mining company. But the goal is to have a really big inventory of materials available for reuse at your disposal when you start designing, so that you have an idea of what's available. And that can be materials from the building sector, stuff that you know, window frames, doors, system ceiling, whatever. But it can also be stuff from other sources like industrial waste, production waste, or anything you can imagine, basically. Fast life waste from exhibitions. And we try to get all that information together on a map so that we have an idea what can we find when we have a project, for example, here in Rotterdam, what's in the neighborhood. And if we have a project in Amsterdam, what's around there, so that we try to harvest as locally as possible. One of the first bigger scale projects that we did with this strategy of superuse or reuse, or however you want to call it as well, is Villa Bello. So it's a modern house for an art collecting couple. And they specifically came to us because they wanted their house to be made out of waste, out of reuse. And the idea for us is not that you have to be able to see that waste materials are used. We want to make good functional architecture that just fits in the neighborhood, fits in the surroundings, fits with what the client likes and what the client wants, etc., etc. So the outside doesn't reveal in any way that 60% of the materials in this building are actually saved from landfill or incineration. And even on the inside, of course, not everything that you see is waste, but also in places where you don't see any material, for example, the insulation inside, there will be waste materials used. So on this harvest map, specifically for this project, you can see that we reused the building elevator. It was used to make the steel structure of the house, and then it was integrated in the house to connect the first floor, the kitchen, with the floor where the bedrooms are. Well, a lot of material, all the facade cladding is cable reels, so we harvested the core of the cable reels. We reused a textile machine that was found at a local scrap iron reseller nearby. We used stainless steel offcuts, like the ones you see in the right bottom, building advertisement boards, and sort of the curtains are made from the sort of mesh fabric that is hanging in greenhouses. So in detail, all these materials come together. For example, the insulation on the inside is the cut out pieces of caravan production. So when they make the walls of a caravan, they cut out the windows, and that insulation material will be thrown away. And we collected that to make the walls, the facades of the villa. So on the facade itself, we did this environmental calculation to understand, okay, how many, what are we actually doing? Are we just designing a nice facade? But compared to a new wooden facade of the same type, we're again reducing over 90% on carbon emissions. So these are big steps compared to, well, just making a new bio-based facade. Same goes for the steel structure. As I mentioned, it came from a textile machine. So on the left is the machine that it was in the past, or something similar. On the right is what we found at a scrap iron seller nearby. And of course, the steel was cleaned, coated, treated, cut to the right sizes, and roughly 90–95% of the steel in the house is made from the textile machine. And we had to add some pieces to either make it fit or to make the crosses or to small things. And again, for the steel structure, the same thing. Almost 90% reduction on carbon emissions, not completely 90%, but still big steps compared to a new steel structure. So it's really worth it to reuse the products that we have and not throw them away, because recycling also takes a lot of energy, because you would have to break the steel into pieces. That's a machine that's doing that. You have to melt it. There's fire, there's coal, there's all these energy that you're investing again to recycle material into something new. So that's Villa Welpelo. That's one of the bigger scale houses that we've done. Currently, we're working on 2 housing projects as well. One in Den Bosch with 20 houses, and one in Rotterdam with roughly close to 50 houses on a renovation project. But on another scale, or maybe more approachable, is this one, Kevin. It's a project that has an exhibition space. It has food and drinks like a bar, but it also has workplaces in a school building that is right behind it. So we added a semi-public facility for the creatives in the school that have their workplace there and the neighbors around. And on that harvest map, you can see that, well, again, we were sourcing locally, like just a few hundred meters away from the site in the city of Eindhoven. Also a little bit further away in Barendrecht, Rotterdam, or elsewhere in the Netherlands. So we're not that strict that you say that everything has to come from the city where you are designing your project, but you try to get preferably heavy things as close as possible, and other things sometimes might be a bit further away. And the way we work is such that, for example, I'll just go back 2 slides. You see the wooden trusses that are well, pretty iconic to the extension. They were not found like that, so we had to figure out a way to transform them to make the right height and size and space for this pavilion. And the way that it's done is to cut them into pieces and reconnect them again with some steel bolts, and yeah, make them into the shape that fits to the site. And the whole building is made in such a way that it's basically only dry connections. We have concrete slabs from an industrial site nearby that are stacked in layers to create a foundation. Within that foundation, the floor heating is integrated. The wooden trusses are put on top, and the facade is connected all around. So this is the pavilion in the context with the school in the background. And one of the important things was that it should sort of mimic the scale and size of the gutters on the old school building, which is a monument. And just this week we heard that we're the third runner-up or second runner-up, I don't know, third prize in the public award for best project in Eindhoven in the past year. So that's quite nice for basically a pretty small pavilion, but they can see the added value to the neighborhood and to the community of creatives on the inside. So going back to the theme of the talk, creating urban ecosystems. Also a bit older project, but this explains it really well, is for a shrinking city in the south of the Netherlands, where it used to be a mining area, but that identity was sort of lost when the mines closed. And they added the Central Bureau of Statistics to that city, but that never really was a right match. So we came up with a strategy to inspire other urban planners how to deal with a neighborhood like that. And we said, okay, maybe food is the new identity of that neighborhood. That shrinking city is, as you can see, it's a mixture of like standard housing, a bit of detached housing, and a bit of industry in the north, some green spaces in between, and a few iconic buildings like churches or school buildings or four-story apartment buildings that were not really wanted anymore. And for all these types, we came up with ideas, solutions to move towards a more food-related neighborhood with more open space and space to store rainwater. And with that came some scenario planning. So you don't have to read the text in the bottom, but the scenario is that when we did a project in 2010, we were looking forwards in steps of 10 years, how to increase rainwater storage in the area, how to deal with the flows of incoming wastewater, incoming fresh water, and how we can mix these flows into something else. And maybe easier to understand here is the flow of food, where you can see that the square boundary stands for the amount of square meters in the neighborhood. And part of it is agricultural land and part of it is used for cattle. And we say that, yeah, it's pretty hard to make more room for cattle, but we can increase the amount of agricultural land. With the increase, we have more production, so we keep our outflow of food the same, our export, but we start to produce more for what we use internally inside the neighborhood. And that helps to create a stronger local economy. As you can see in the flow of money, where there were quite some people on welfare, the light blue image. And in that plan for a couple of decades, we wanted to reduce the amount of welfare, create new jobs inside the neighborhood, where these people would have locally earned money that they spend locally, and this way creating a stronger local economy. And finally, looking at the flows of energy, so you can see gas use is pretty high, gasoline for the cars is pretty high, and there's a little bit of electricity for, just appliances, and of that, a very small amount is generated by PV panels. But by adding a PV factory in the neighborhood, because they were mining the silica there to actually produce these panels elsewhere, we're increasing the amount of solar panels over time so that it can fully supply the local needs for appliances, but also parts of charging cars and heating, and adding greenhouses to the houses to capture the waste or the lost heat, reuse it partly to grow crops, and also to feed back some of that energy through a heat exchanger. So how that all comes together is this vision of, in 2010, there are certain flows, local flows, regional flows, national flows, and international flows, where food comes from, the energy comes from, etc., etc. And well, the relatively boring street, back alley street structure of that neighborhood, where we envision that it can be transformed to one street becoming more a park-like landscape, because more local economy means less cars, less people means less cars, so we can reduce the amount of streets. Some of the courtyards or the back gardens can be converted into shared spaces, greenhouses, where you extend the living area of your house into that shared space. And for example, that looks like this, that in the neighborhood itself, you build a complete structure around it of reused window frames to basically give the old houses an extra jacket. Or this is a bit of a tough image to load. Or, well, creating these water landscapes in between the houses. And as you can see, the darker blue elements in that scheme were the elements that were already there. And all the light blue elements are objects that we added to that system to create that local ecosystem. And well, the elements that we add, we call them cyclifiers, so elements that help you to close loops, to close cycles in a neighborhood. So of course, the images are, I think, yeah, over 10 years old, so currently we will make them a little bit nicer, but still it represents the idea of what the neighborhood could be quite well. So bringing nature back to the city, transforming the sort of leftover parts of green to a place where you can see cows again or see goat again. That was all a study, something hypothetical, but we're actually doing that right now in Blue City in Rotterdam, where we have our office as well. So I'm currently in this building, and this used to be a subtropical swimming paradise, a place where people from Rotterdam and the surroundings would go for a day a year or every, I don't know, every other month to enjoy like a wild water tracks, slides, sauna, all these things. And we had actually been inside when the swimming pool was bankrupt to harvest materials for another project. So it looked roughly like this when we were there. All the plants had died. We actually managed to save some of them, and they moved with us with our office a couple of times, and now they are back in this building again. But that building, well, the swimming pool was bankrupt. There was no one really willing to start over as a swimming pool, and we came up with a plan for Blue City, and we formed a team with Holz, Koop, Ivan, and some others. But most importantly, an investor that was willing to go with us to an auction and buy this building to transform it with this idea. Where the vision in general was, we are not going to make one design, we're going to execute it completely, and then it's finished, and then we have a grand opening. But it's a vision that we can slowly develop in a couple of years, looking, well, 2 years ahead all of the time at the companies that move in and the companies that move out, slowly filling and redeveloping the building, looking at the flows that they have. So do they have paper waste? Do they have waste heat? Do they use a lot of electricity? And while mapping these flows, trying to find other connections and other buildings that or companies that could come together in this building and benefit from each other. So for example, currently we have a brewer, of course they have waste heat, we have some catering, we have a restaurant, all the coffee waste is collected for Rotterdam and they will use it to grow mushrooms, etc., etc. And of course the space itself is transformed with waste materials like window frames, but also the chairs, the tables, the carpet, the electrical gutters, the lamps are all coming from various local sources. And here you can see it all coming together in a harvest map for Blue City. So a lot of materials have different locations where they are found, different distances from the site they are collected, visualized here in a section where they end up, and shown how much carbon reduction is saved by reusing that instead of buying new materials for it. And on total, for this office renovation project, we reduced roughly 68% of carbon emissions compared to a regular construction. And in the past year, we opened Blue City Lab in the basement, which is a really nice new addition, where we have a wet lab and a dry lab where new circular or biomaterials are developed by a group called pioneers. So they're working with fungi and with seaweeds, trying to develop the materials for the future. And in the dry lab, they have the tools to see what they can do with these materials, like CNC milling, woodworking, bending, whatever. And also for Blue City, we did that for the Blue City Lab, we did the calculation that we roughly reduced 112 tons of carbon compared to traditional ways of making such a space, which is the equivalent of driving back and forth between Rotterdam and Paris for 652 times. So all these things matter. So every small design choice you make matters. And finally, of course, we envision together with Superuse China even larger projects. And this is a vision for a wastewater treatment site. Currently, you see that the drain is almost empty. There are these two round tanks in the middle and some structures around it that together form a wastewater treatment plant. And when we drew the system boundary of that whole site, we saw, okay, there's quite a lot of potential to add new functions. And these are the things that we could imagine that might fit well. All the flows that would be connected because of these functions, everything on site within the same location, and how they would spatially be related to each other, what kind of things go well together and what things should be a little bit further away. As you can see in the left bottom, it says no daylight needed, for example, for the parking or technical spaces. Well, we've drawn up a rough section of that where the wastewater treatment plant will stay functioning while the new building around it is developed, and also afterwards. So there's two round circles in the middle, they are still there. Some of the bigger tanks of the wastewater treatment plant are still there, but around that, a sort of big resource valley can develop to create a showcase project for what the blue economy could bring for China. So that is what I wanted to share with you today. Thanks for your attention.